Hey everyone, happy Earth Day. I hope you all had a wonderful weekend. And for those who celebrate Easter, I hope it was a great day for you and your family. Welcome to today's webinar on how to build energy efficient homes and why sustainability is a viable business. My name is Ingrid Velasquez. I am the Chief of Content and Marketing for Fohlio. Some of you may already be familiar with me, and some of you are also Fohlio users. For those who are not, Fohlio is a platform for architects, designers, engineers, contractors, vendors, and basically everyone in the design build industry. Fohlio makes product specification easy and effortless, and our software also helps streamline the creation of product schedules, purchasing, invoice, creating documents, and more. If you would like to know more about us, please go to fohlio.com and we would be happy to set up a one-on-one demo with you. Today, we have the honor of hosting Scott Sanders, who is the CEO of Brightleaf Homes. From a very young age, Scott knew that he wanted to be a builder. He founded Brightleaf in 2008 because he believes in making a positive environmental impact, especially in Chicago and its suburbs. So today, Scott will be teaching us what exactly it means to build a high-performance home and why energy efficiency doesn't just mean a sustainable planet, but also a sustainable business. Before I hand the presentation over to Scott, please remember that you can type in your questions in the little question box on your screen, and we'll have answers for you after the session. And without further ado, here is Scott Sanders.
Good morning, or good afternoon, or good night, wherever you are and what time zone. I know Fohlio is across the globe here, so I'm happy to be chatting with everybody that's on the call right now. Again, my name is Scott. I am a residential builder and developer in the Chicago area, and it is about 11 o'clock it's noon here, so just about lunchtime. Hopefully everybody in the Midwest is enjoying lunch while watching this Earth Day presentation. So what I am going to be talking about is exactly what Ingrid mentioned, is high performance homes, energy efficient homes, green homes, whatever you might want to call them. That's what we're doing, and that's what we're trying to have come to market more, both in the Midwest here in the Chicago area and across the United States and into Canada as well. What I'm going to cover in this presentation is a little bit more than just green home building. I'm going to use the term high performance homes quite a bit. And throughout the presentation, I'll explain why we are trying to move towards high performance instead of just green. And the core reason and the teaser is because energy efficiency just isn't going to cut how we're going to have to build homes in the future. So I'll go on here a little bit, talk a little bit about Earth Day for a second. Earth Day first started in 1970. It was actually a response to an oil spill near Santa Barbara, California, back in 1969. So this is before Exxon Valdez. This is before, obviously, the Gulf Coast oil spill, and a lot of other events that caused environmental impact. But this sort of galvanized the country into some sort of action around protecting the earth and being a responsible steward of the natural resources that we have here. Unfortunately, since that time in 1970, things have gotten better, but not gotten perfect. And so we still deal with a lot of smog. And we still deal with building durability problems. And that's where green and energy efficient just won't cut it. That's where high performance starts to come in, is building durability and building better homes, not just more energy efficient homes, but ultimately homes that are going to last longer, homes that are not going to find their way into the landfill, and homes that are going to contribute to healthy indoor air quality for the occupants that are inside of them, since we probably spend what I think the national statistic is 16 to 18 hours a day inside homes, office buildings, and things like that. So indoor air quality, durability, and energy efficiency all roll up into the term of high performance building, whether or not that's for residential, commercial, industrial, schools, whatever it might be. So that's just a little bit about Earth Day, and we'll go on from Earth Day there and start talking about what we're going to cover here. We're going to talk about what Brightleaf is, what high performance building is, sustainable design, and why it's important to understand and incorporate it into what you're doing both in design and build. And then we're also going to take a quick look at the practical aspects behind the curtain of Brightleaf and what we do and how we do it, both from a design standpoint, from a specifying materials, assemblies, plans, and things like that, but also from a practical building standpoint. We are not technically a design build firm here in Chicago. We do work with outside designers and architects and engineers to develop our plans, but we're very heavily involved in the design of those plans and making sure that they holistically meet our approach to sustainable building, sustainable residential building. We're going to wrap things up at the end. I'll take only about 20 to 25 minutes to chat here and show you a few things in slides. We've got about 20 slides, and then we'll end with about 20 to 25 minutes of Q&A. So as you come up with questions along the way, please don't hesitate to type them in the chat window over to your right, and we'll just kind of bank them all together, and Ingrid will pick a few at the end, and we'll go through answering any questions that you have. So let's keep going. I mentioned that we're based here in Chicago, and believe it or not, Chicago does have water. We've got a pretty big river and a pretty big lake. That being said, we build primarily infill new construction homes, and we build them all to third-party certification. So Chicago is a cold climate, actually climate zone 5A in the U.S. here. And with that climate zone comes specific design guidelines for how we have to build homes in terms of energy efficiency and the general energy code by which we build. The certifications that you see that popped up on the screen for EPA's Indoor Air Plus, Energy Star, and the DOE Zero Energy Ready program are all above code building programs. So here in the Chicago area, we have the Standard Building Code, which is the 2018 International Energy Conservation Code, along with regular building codes, international residential and mechanical and plumbing and things like that. And then these programs that I'm going to talk about in more detail in just one second help guide us towards building homes that are beyond those codes, essentially set up for future codes and future building. This picture that you see on the screen here is actually one of the homes that we built. You can tell that it's an existing neighborhood. We've got a mature tree in the front. There's a neighboring house that looks pretty old next door, probably with a second-story addition. And this is primarily what we do at Brightleaf. We build on scattered sites, one-off properties, not in large developments. And in total this year, we'll build between 24 and 27 homes on this scattered site model. We are 100% committed to these three certifications that you see on the screen here, and why we are committed to those and what those certifications are, I'm going to talk about in 1 second. I also do want to point out on the right side of your screen, the Zero Energy Ready program is not just a certification program, but also has competitive awards, as does the Energy Star and the Indoor Air Plus programs. And for the past 4 years, we've actually been elected and awarded for the Housing Innovation Award for the DOE Zero Energy Ready program, which is one of the reasons I get to chat with you now about what we do. Going on, just a little glimpse about Brightleaf here. Brightleaf, again, we are building semi-custom infill homes in the Chicago area, and we are focusing primarily on a target market that is interested in living in a better way. So healthy, smart, custom. This is actually just a screen grab from our website, and this gives you a little bit of a view into how we market, how we approach green building and high-performance building, in that it is not just tree-huggery, hippie, I'm going to go out and save the planet, because that we have found actually does not work in our market. We sell actually very few homes to what I'm a tree hugger, so I can say this normally is what I say. We build very few high-performance homes for just tree hugger type people. We build a lot of homes for young families. We build a lot of homes for empty nesters. We build a lot of move-up homes for clients who are interested in having a better built, longer lasting, more durable home with energy efficiency and the greenness of it kind of being a side benefit for the icing on the cake. Here's what we're not, unfortunately. We are not old school builders, and there are a growing contingent of builders in the United States who are participating in these above code programs, anything from LEED to Living Building Challenge to USGBC and the National Green Building Standard, those kinds of certifications that are trying to build the homes of the future and not the houses of the past. And so the old way of doing things, frankly, is dropping a bunch of sticks in the front yard, designing the home on a stock set of plans, maybe 4 or 5 pages long, building without any sort of specifications, hoping that the builder is going to execute the plan properly out in the field, and then kind of taking all of this lumber and just throwing it together. This is a picture that actually that's taken from a job site around the Chicago area, and there's something terribly wrong with this picture. This house is mostly built, and there is a lot of lumber left laying in the mud in this front yard here. Obviously, it's been raining, it's exposed to weather. House wrap detailing on the house behind in the background isn't very well installed. All kinds of things that are wrong with the general home building industry today, which is where high performance building comes in. High performance building being, again, building better than code and having a holistic approach to how things are built. Keeping up with that and keeping up and ahead of code and ahead of the curve is important. And that's why this goes beyond high performance building and it goes to high performance design, high performance specifying of assemblies, materials, details, all that kind of stuff, because truly it is going to be the way of building for the future. This is actually a graphic of a model 3D printed home. So this is a home that's essentially extruded with concrete and through the, trellis system there, and floor panels that are stacked on the ground and put into place mechanically as well. There's an operator down there. What probably is going through your head right now is, oh, that's cool. That'll probably be around in 20 years or so, and we can all do what we're doing now and just be okay. Unfortunately, we can't. So 3D printed houses are actually a thing. This is a picture of a home that was actually built in California, or I guess extruded in California, for lack of a better term, using that 3D system of building homes. So the point in illustrating this is that the homes of the future are coming faster than we might like to think. And if we don't keep up with the homes of the future and stay ahead of the curve as designers, as builders, as architects, then we're going to get passed by or become obsolete as these other technologies come to take over the market and become more relevant faster than we think. We, as Brightleaf, and some of the other high-performance builders across the country, are still building conventional wall systems for the most part. We're using 2x4s and 2x6s and super insulating those with exterior insulation or insulation in the wall cavity. We're building regular concrete or concrete block foundations and traditional stick frame roofs with asphalt shingles. And that right now is above and beyond what a lot of other builders are doing across the U.S. We, however, as high-performance builders, are even being eclipsed by other firms who have much more of a technology mindset and much less of a building design and architecture background. And two of these are up here on the screen. Blockable is a company out on the West Coast, along with Entekra, another company out on the West Coast that does either modular, truly modular, prefab designs, systems building, all kinds of stuff that is very, very futuristic. And there are a number of other companies that I can't fit on the slide here that do high performance, higher than high performance, I should say, building across the country and are truly just trying to take over the market with technology. So this is where our eyes as Brightleaf are looking, is how do we mimic what these component and modular builders are doing? How do we stay ahead of their curve so we as ourselves as a company even don't become obsolete? The graph that you see on the right here, next to the graphics for Blockable and Entekra, is a pretty typical curve that you'll see if you're ever into technology for adoption of smartphones or adoption of even wireless phones instead of landlines, LED lighting, all kinds of things follow this general technology adoption bell curve. And what we find actually is that we're operating right now around this position when it comes to the future of housing, being component built, being built in factory, being prefab offsite or something. This is kind of where we are. We're just starting to cruise up the curve here over the next 10 to 15 years. And very, very quickly, we're going to get into the early majority where we're going to be in the double-digit percentages of homes that are built with high-performance technologies, assemblies, and materials specified on the inside. So Brightleaf and the other builders who are trying to stay ahead of the curve, frankly, are trying to get up that curve faster than some of the other production home builders and some of the other conventional architects and designers who are designing houses of the past, still using built-to-code standards, old details, just 2D plans, and older finishes, frankly. High performance is awesome, but of course, high performance costs more, as it should. High performance homes are better performing, they're more durable, they're longer lasting. And because of that, I would hope that people would expect to pay more for them. They also take more effort to design and specify. They take more effort to engineer properly and more money to engineer properly, frankly. and they should cost more, just like you would understand you're paying more for a BMW or an Audi car than you would for, say, a Chevy Aveo or some small domestic car with two doors, let's say, as a hatchback. That all said, high performance actually, when you look at total cost of ownership, shouldn't cost tremendously more, because ideally the long-term maintenance costs, the long-term utility costs, and the insurance costs or health insurance or healthcare costs for families living inside those homes would be lower than you would typically find. So calculating the cost of a high performance home is extremely complicated, and you have a curve and a graph. No. Ideally, the cost of building a high performance home should be pretty linear. As you put in an extra dollar of insulation or design in an extra LED light fixture or high performance efficacy lighting, you should see that dollar back along the way. What we've actually found in designing, building, and specifying for high performance homes is the cost benefit curve looks a little bit like this. There is a lower incremental cost for higher benefits until you get up to a certain point where the inflection changes and it starts to level off, where you just start spending more money without seeing a significant improvement in benefit. We kind of associate it with a hockey stick, an inverted upside down hockey stick, to get the graphic in your minds a little bit easier if you live in an area where hockey is the thing. That said, Brightleaf as a company and some of the other high-performance home builders who are operating right now are trying to build and operate right around the point where that arrow is indicating, just before we get to the flattening out of cost benefit. So we're trying to increase the performance of our homes to decrease total cost, to decrease operating costs, while still having a reasonable benefit that makes economic sense along the way. This graph is also useful for talking about above code building programs. And so why high performance home building is relevant to the market is because there are third parties who can certify homes and buildings, office buildings, schools to be above code buildings that meet these third party certifications. So some of the third party certifications on here are the Energy Star program, which is from the EPA. It's similar to the dishwasher that you have, or the refrigerator that you have, or the light bulb that you might have put in that's rated for Energy Star. It essentially says that the home or the product is more energy efficient and will last longer than a competing average product on the shelf. As you go one step up from Energy Star and one step further up in cost, frankly, but also one step up in benefit, you get to the Zero Energy Ready Home program from the Department of Energy as well, where that program takes into account all of the things that are in Energy Star and then layers on top of them a few more things about durability, about energy performance, and about being solar ready, solar PV ready, photovoltaic ready along the way. The National Green Building Program is also on here right around Energy Star level in terms of performance requirements and cost benefits. But going down the curve before we go back up is the newest International Energy Conservation Code. I said that Illinois is on the 2018 code. A lot of the rest of the country is on the 2003, 2006, or 2009 codes, which is frankly building houses of the past again, as I said. And going back down one more step, frankly, to the left and lower left, again, building below code technically means that you're building something illegally and could go to jail for it. I've never heard of an architect or designer being thrown in jail or a builder being thrown in jail for not putting enough insulation in the wall, but it is ultimately a possibility there on that end. Going back up the curve, onto the blade of the hockey stick are programs like Living Building Challenge or programs like Passive House or PS homes, and from our cost benefit analysis, in the near term, those programs haven't gotten to the point where they make financial sense for speculative built homes. And so I'm not saying that those programs don't make sense from a cost benefit standpoint, but those programs require a lot more energy efficient features. They require a lot more installation and detailed wall assemblies, advanced mechanical systems to be specified, engineered, and installed that can often make the cost of those homes and the cost benefit not quite pencil out. Those programs are extremely important, however, and that they're pushing down the adoption curve for technologies to be more cost effective for programs like the Zero Energy Ready or Energy Star, and eventually, frankly, like the International Energy Conservation Code, which would essentially be building a home to code. So those programs, again, extremely important, and the details and assemblies and the checklists that go into them are very, very necessary for helping to push this market forward. How do you get these third-party certifications in the homes that are built? Well, we go through what is generally a checklist regardless of the program that we're participating in. So all of the programs that I illustrated on the previous slide are checklist-based programs that you fill out a checklist to ensure that you are designing and specifying a home properly upfront in the beginning to make trade-offs as much as you can in the design portion for the most part, and the pre-planning of the project. As you go through the project, you're of course building to those specifications, building to the designs, building to the features and the assemblies. And then at the very end, we have a third-party inspector that comes in to verify that all of the things were installed, all the things were installed and detailed properly, that are called out on the plans, that are incorporated into the design and the preliminary rating, frankly. This is an example of the LEED checklist from the U.S. Green Building Council, talking about things that are not just related to the building envelope, so locations, sustainable sites, materials, where you get them, where they're transported from. This is an example of the Energy Star's HVAC checklist. So along with general energy efficiency, things have to be installed properly, but they also have to be tested to make sure that they're functioning how they're intended to be installed and function. So Energy Star has a number of checklists, as does LEED and the other programs that participate. This last one is from the Living Building Challenge here. Living Building Challenge, again, another checklist format that is taking into account things that are just beyond energy efficiency, which goes back to my comment at the beginning that we can't just build green, we can't just build energy efficient, we have to be building high performance. Energy efficiency as its own on a standalone doesn't really sell. I mentioned this earlier, and this is a great reference to what energy efficiency could look like. So this is a fairly terribly designed house. I hope that all of you on the call will agree with that, but it's probably an extremely energy efficient home. Has very, very few windows, has very little wall surface area, has a very simple roof design, and is probably pretty darn cheap to build. I'm sure this scores great, and the utility bills on this home are very, very low. Unfortunately, I don't think that many of you on the call would want to live in this home or own this home and invite your friends and neighbors over to check it out. Doesn't have very good design, is not very welcoming from the street, and probably doesn't have a lot of good natural lighting that's encouraging daylighting through spaces on the inside. So this is an example of one of the homes that Brightleaf built recently in one of the suburbs of LaGrange, and we're looking at the home with the south-facing elevation to the left here. You can see all the windows that are on the south-facing elevation, taking advantage of passive solar daylighting and heating, frankly. You can tell that we have very deep overhangs that are shading the home right to the bottom of those windows, so preventing the summer sun from getting in those second-story windows. But in the winter, where the sun is lower in the sky, we're going to have all that natural light coming in. We've got LED lighting throughout the inside, which you can't see, but in general, sustainable landscapes on the outside, sustainable site design as well, that go into the high-performance building and third-party certification, the bigger picture of the checklist as well there. This home obviously is very appealing. It does not come with a Nissan Leaf that's parked in the driveway, but this is a marketing picture that we put out to try and point out that energy efficient doesn't have to be ugly. Energy efficient doesn't have to be compromising in anything. Energy efficiency in high performance building can be everything that you wanted it to be, and everything that a client and consumer wants it to be, except gold plated toilets, I guess, let's say. Going back to the cost and benefits design, that's probably not a dual flush high water efficiency toilet on the left, but it is very, very nice. The kitchen on the right, amazing chef's kitchen, certainly could be installed if energy design guidelines are incorporated with LED lighting and fixtures and things like that. But what we see most often are very nice finishes that are conservative, that don't cost a phenomenal amount of money in homes that we build here in Chicago. So our average selling price point is move-up buyer. So often our families are coming from an existing home or townhome or condo or something, moving up into one of our homes. And so the finishes that we're specifying, the designs that we're planning are fairly moderate. They're not that chef's kitchen of the picture before. We install dual flush toilets. We install, as you can see, hoods, high performance exhaust hoods, LED lighting, hardwood flooring that's got no VOC coatings on it, chlorine solid surface countertops and low VOC cabinets, all these kinds of things that contribute to healthy indoor air quality and just better performance for the family that's living in it without going too far overboard with what our families are able to afford on a monthly basis. So we're going to jump into the second to last section of what we're going to talk about, which is how do we actually execute this after it's been designed, after it's been conceived of by the client or by someone here in our office? And the answer to that goes to a lot of pre-planning, right? So proper planning prevents poor performance. We strongly believe in complete plans and specifications for projects before we start, and we'd also believe in the design-build philosophy of making sure that we have an integrated design team up front that is not only doing the design and engineering and architecture, but also interior design and exterior landscaping design, all of that stuff that will contribute to a successful project that's built on budget and on time. So each one of our projects starts off obviously with a full set of plans and a full set of specifications. We have a 60-page and continue to grow specification guide that covers all of our projects. And that specification is written, it has graphics, it has details, some of which I'm going to show you as we go through the slide here in more detail. Going back to specifying briefly as we're talking about plans, some of the things that we do to build high performance are fairly simple and straightforward. It's just done a little bit better, or it's actually following the manufacturer's recommended installation instructions. It's amazing how energy efficient, how durable, and how healthy a home can be if you just follow what the directions say. A good indicator of this is wall insulation. So this is a conventionally framed wall here that has some fiberglass insulation. We're actually standing in the garage of the home. This is another competitor's home in the area, and we are looking into the mudroom area on the other side of the wall. What we see here is a poorly installed fiberglass insulation installation. And so those fiberglass bats, ultimately all insulation, is meant to fill the entire cavity of whatever it is installed into, with no voids, gaps, cracks, or anything like that. So what we see here is actually an installation error that will lead to a poor performing wall, because we will have thermal conductivity going through this wall a little bit, and then we'll also have some convective loops, which will decrease the performance of this insulation overall, and frankly just make that laundry room that's on the other side of this exterior uninsulated garage pretty chilly in the winter or pretty hot in the summer. An alternative to that is dense packed cellulose insulation. This is what we use on a lot of our projects actually, where this, you can see, completely fills the cavity. So when drywall is installed on the face of this wall, that drywall will be in contact, the back side of that drywall or gypsum board will be in contact with the dense packed cellulose insulation there. Dense packed cellulose is essentially blown into a wall cavity with kind of a reverse vacuum. So it fills in all the little nooks and crannies, and you can see that down on the right side of the picture actually, where we have some electrical conduit that's buried in the wall that the insulation is completely behind and just a little bit in. Same thing with some electrical boxes there. One more thing to notice on this is actually the air sealing detail. Very, very simple air sealing detail that will yield energy efficiency benefits and lower utility bills for your clients. Is just specifying sealing of the bottom plate in the corners. You can see a bead of white caulk that goes down along the bottom plate there. There's also a gasket separately underneath that wall. It's kind of a belt and suspenders approach. And then there's another bead of caulk going up the corner on the right side of that illustration too. I'm sorry, the right side of the picture as well. One of the last options, or more common last options for wall insulation, is actually spray foam insulation. This is a poorly installed spray foam insulation job, unfortunately, where the installer was inexperienced and wasn't quite sure what the mixture should be and how the components should be used. And that's one of the reasons that we don't use a lot of spray foam insulation in our homes. To be clear, we do use a little bit of spray foam in the areas that are difficult to air seal or insulate properly with cellulose or fiberglass insulation. But in general, spray foam insulation is not a material that we believe has kind to the environment overall, and frankly is more difficult to install and more prone to installation error and misses in performance. Again, as I said, spray foam has its point and its area, and we do use it. If you do specify it, please make sure that you are specifying a particular mix that you're comfortable with in terms of its impact on the environment, and then also please make sure to specify that the installer should be certified and should be able to provide that certification document to the designer as part of the design team or to the general contractor before they begin installing. We want to make sure that everybody's trained again to follow the manufacturer's instructions. Big surprise. Another detail that we have in our standard specifications, that 60-page document I told you and mentioned, is very simple framing plan details. So 2D plans are phenomenal, actually. Unfortunately, 2D plans that we see a lot of traditionally are black and white copies, and again, maybe 6 or 7 or 8 pages long for a single family home. We want to make sure that floor plan and joist layouts are completely thought out. This is a 2D floor plan overlaid or underlaid, I suppose, with the joist layout. The joist layout is color-coded to make sure that the right joists are being installed and cut in the right locations. And we've also overlaid, or made sure the designer overlaid, the plumbing and the floor plan to make sure we don't have intersecting walls where we can't have them, or toilet flanges, or sinks, or whatever it might be that would interfere with a floor joist layout. So just a little bit more proper planning here on floor systems. Other thing that we do and make sure that our designer and architect specifies is actually wall panel layouts. This is an effort to make sure that we are using materials efficiently on site. Building green, again, this is more than energy efficiency. So the less material, the less natural resources that we can put into our homes and still have them perform and be structurally sound, frankly, the better for us. So this is actually on the green layout that you see in the center of the screen, a layout for cutting our full exterior sheathing of our homes to make sure that we're using it effectively and efficiently. On the left side would actually be a weather-resistant barrier layout if you're using Tyvek or Dow wrap or home slicker or something, that you would be able to have the proper lapping and, frankly, the proper roll sizes to make sure that that material is also being used effectively and efficiently and being installed. Color-coded graphics are much nicer in the field. Obviously, our framing and our carpentry contractors and subcontractors can read 2D plans. That's what they've done for a long time. But if you can make something much more simple to understand, then you very much increase the odds of it being done properly right the first time without rework that's going back to do it. A couple more details here on basic framing and planning. We plan and have our architect insert details for insulated sandwich headers in all of our plans. What you see on the left, which is essentially a header on the outside and on the inside, providing surface for nailing of trim and window flanges and things like that, and also obviously carrying the structural load. But in between that, you'll see a pink and another layer of insulation that provides that to be insulated. So on the right side is often what we see from other homes in the area that just have absolutely no space for insulation at all anywhere. And so ultimately, this is a cold spot in the house in the winter where you could actually have condensation and potential moisture problems since there is no insulation there, but there is insulation next to it in the wall cavity. And frankly, that's also a terrible use of wood. In this case, that header is way oversized for the load that's above it because there's another window that is stacked directly above it. And the framing to build down that opening is just kind of a lazy waste. So again, not a great use of natural resources, not a good use of time, frankly, for the framer that put that together, and then also absolutely terrible in terms of energy performance. I want to point out one thing for a moment here, in that this format that you see on the screen, this, not that, is something that we use a lot of our times with our trade partners as well. We want to make sure to take a picture of how not to do things and have it be very clear to our trade partners, to our subcontractors, what they should not do and why, and then give a picture in that specification guide of what they should do or why they should do it, to make it very clear, again, in 3D and full color in the photograph, if possible, what should be being done instead of something else that might be typical for an industry or typical for an install. Another detail here actually is our foundation flashing that we very carefully engineer. We use exterior insulation on our foundation instead of interior insulation, and that ultimately yields to a what we believe to be a more comfortable interior home that kind of buffers heating and cooling loads. But also it's a little bit of cost savings because we don't have to protect that foam board insulation that is on the inside of the foundation from flame spread, where you would have to cover it with drywall or some other flame or ignition barrier on the inside. So in this case, we have an energy efficiency measure that's also helping to reduce cost of the buildings that we were building to some extent here. Again, 2D plans would be phenomenal here. 3D color-coded with details and very clear notes. We found that our trades are more receptive out in the field to something like this instead of simple black and white plans. This is just a picture of that actually installed in the field to show that reality can be possible based off of what's on the plan too. Here, we've only cut the back section and tapered the back section. Ultimately, this is tapered to make a transition on the outside to be aesthetically pleasing, so you don't have a shelf that can hold water or snow in our climate. And then that gets covered with as you see in the previous screen, a sheet metal flashing that goes down below grade and kind of hides all of that nicely. Continuing to go forward, this, not that again. This is important in specifying and designing mechanical systems. High-performance buildings aren't just durable, they aren't just energy efficient because they have more insulation in the walls. Hopefully they're energy efficient because they have advanced mechanical systems that are carefully designed and, thoughtfully designed and carefully installed. On the left is actually a high-performance Panasonic Whisper Green fan that exhausts straight to the outside in one shot. That duct run is about 5 feet long. That basically guarantees that the condensation that's from the shower in this bathroom is going to be exhausted straight outside without damaging the interior of this bathroom. On the right side, not that, we have a very cheap fan that probably will not actually exhaust any air from it and ultimately yield to condensation and moisture problems on the inside of that bathroom. The duct layout obviously isn't helping with that. We have a flexible duct that's run through the attic with 2 kinks in it and probably will be stepped on or covered with insulation and crushed a little bit more as well. Just not a great installation. So as you're designing and specifying plans, please don't forget to think carefully of mechanical system layouts, how ducts are going to be run, where you can get things through to make sure that the installer doesn't have to think through that in the field where they will be less likely to take the proper time to carefully install and put in that system. Last detail here is moving towards trying to stay ahead of the technology adoption curve. We have a very integrated design process up front, but then we have a very integrated execution schedule and system on the back end as well for our trade partners and internal staff. This is a Gantt schedule, which is just showing all of things that are going on throughout the course of a project, and on the right, how they relate to each other, what has to come before something else. The next iteration of this will be to layer it onto a 3D model like we have here, which is BIM, Building Information Modeling, to generate a 4D model. So not only building this home virtually in 3 dimensions with components and pieces and things like that, but doing it linked with the schedule that we are showing to our trade partners or showing to the client, so they can see literally over time on Monday, April 22nd, my home will have the 2nd floor roof on, and here's what that looks like in the 3D model that I can see. Technology is going to, as I said before, come faster than we probably might like it to, and the earlier we can get on this bandwagon, the better, frankly, because it's going to help us design and build better homes and ultimately make much more satisfied clients and customers who can appreciate the effort and the intent that all of us as design and building professionals put into the product that we're putting out onto the market. So I told you that I was only going to go for about 25 minutes and try and leave a lot open at the end for questions and answers along the way. I do think I went over just a few minutes, but I hope that we have plenty of time here if I can answer things specifically related to high-performance building, to specification and design of high-performance buildings, primarily related to residential and light small multifamily, or anything that we actually do for any specific terms or details for the models or methods that we use on the design side or actually on the build side. I appreciate all of you listening to me for 20-25 minutes or so, and happy to answer any questions as you put it in the Q&A on the right side there. Please also don't hesitate to reach out to me. That's my cell phone actually, and my email address there. If you have more detailed questions or follow-up later on, you are certainly welcome to reach out there as well. But if you have any questions, please throw them in the question box on the right side. And Ingrid, I'm going to turn it back over to you to moderate that.
Awesome. Thank you so much, Scott. So that was actually super informative to me in that I didn't know that. I thought saying high performance was just another kind of version of an eco-friendly or green home. But now I know that it's a lot more than that, in that like you said, you build it way better, and so it lasts longer. And I guess that's another way that it's better for the environment, and overall it's also a really good and viable business idea. And
it absolutely is. Yep. Thank you for bringing it back to that. That is what our business is based on, and we're seeing a lot of other builders across the country come up to that business concept as well. Those are builders, again, that are trying to get ahead of it. I think that unfortunately, as I said, on that adoption curve, there are going to be builders that are going to get dragged along that evolution and adoption too, and where the business model will be forced to change for them instead of them trying to electively change it before it becomes the swelling tide, I think.
Right. So actually, that's a really great segue into my questions. We do have a few questions that came in, but I will take advantage of my role here and ask mine first. So I saw an article in the Atlantic talking about why builders are building these homes that look almost exactly identical, and how they would describe it is it's these homes that are 2, 3, 4 stories high, and then they would have a commercial section under it. And essentially, the reason for that is that that's the fastest and quickest way um, to build cheaply. And instead of having to, use more expensive materials so they can build higher and be more creative with their design, that's what they do. So basically my question is, in this kind of environment, how do you see high performance building in the next 10 to 15 years? And, how do you think it's going to catch on?
That is a question that is being hotly debated, and frankly, no one knows the answer to. When you look at the adoption curve for true technology-related things, like the smartphone, like 4G service, frankly, like desktop computers, the curve is much faster than anybody thinks up front. Landline telephones, for the most part, are a thing of the past, and they went away very, very quickly once cell phone technology and 4G came around to supplant those and made them unnecessary. I would bet that 15 years ago, nobody would have thought that landline phones were going away and that people would be streaming Netflix videos on their phone while driving across the country. And
Right.
so whatever prediction I can make or anybody else in the design, build, or construction industry can make, I think it would come faster than we believe. Obviously, 2020 and 2030 are key years from the architecture challenge from the American Institute of Architects. And we are moving towards building high performance homes faster than ever. Mandates in California are pushing that locally. On the West Coast, and other green building programs and model building codes like the 2018 IECC are pushing those much faster than we think. That's just energy efficiency. However, that doesn't take into account necessarily that high performance home building, which you mentioned. And I believe what I would forecast would be technological solutions coming from entities outside the building industry, like Blockable or like Entekra or Japanese or European companies that are coming into the U.S. and truly kind of shaking up how homes are being built now and will be built in the future. And that's going to be even more important for design and architectural professionals to stay ahead of that curve. And, a design and architecture professional still has a very relevant position in the building of a home, because a 3D printed home would be great, but it definitely will not have the character, the hideaway, the nooks, the crannies, the thoughtful design that a fully designed, specified home would, which is what I assume that some of our audience here on the phone is for.
Right. Awesome. Okay, so we have a question from Catherine Schumann, which is actually also super closely related to Kathy Korgard's question. What language do you use to help educate consumers / open them to the idea of an energy efficient home? And Kathy is asking, so do the products you use cost more in general, and how do you sell this higher cost to your customers?
Sure. Catherine, the language, I think that was your question. The language that we use is not green. It is not tree huggery. It is not features. So we're not talking about our 3 inches of XPS insulation. We're not talking about our integrated design approach that yields better cost benefits, all this mumbo jumbo that can be hard to digest and understand. We try and talk truly in the benefits of high performance building: comfort, durability, lower maintenance, better indoor air quality, all these things that will truly impact how a family or how a client, if they're a single, whoever it might be, will live in the home that we're designing and building. And the more that we can talk about benefits and not features, the better that we can be on a larger market approach. We certainly can talk technical features with the right client when they come along, but they are a little bit fewer and far between for those who want to know the fine technical details of why we are air sealing with 2 layers of caulk and a gasket on the corners of our wall assemblies that are all, I could go on and on for that. Kathy, Ingrid, can you remind me of Kathy's question? I'm sorry. And that was, the benefit of selling the cost. So yes, these homes cost more upfront, and they should. Again, going back to the BMW or the Audi analogy, what is different is that these homes, high-performance homes in general, should have a lower total cost of ownership to offset that higher upfront cost. So in our financial models that we show to clients, we're actually balancing out the upfront cost of a conventionally built home to the minimum building code that we have, what your projected utility bills are going to be, what your projected maintenance is going to be, and then we compare and contrast that side by side, actually, with some amazing marketing material with the total cost of ownership for a high-performance home, which has lower utility bills, which has lower maintenance costs, and then not even to include the presumed benefits of better indoor air quality and lower healthcare costs. So that's probably a legal minefield to step into, that we're going to guarantee our homes, cure asthma or something, which they don't. As long as we have the right consumer who can understand first cost is different than total cost of ownership on a monthly basis or over the time that they own their home, then we are well on the way to selling them a high-performance home, because frankly, the benefit is there if you can just take a reasonable long-term cost view and understand the finances of it. So that's our job, to help educate clients on how to understand that and why it's important.
Okay. And Yoshi is asking, do you require specialized knowledge from your builders? Do you hire builders that already have that knowledge, or do you hire and then train?
Sure. It is a combination of all of that. Obviously, we would prefer that our plans and our specifications that are designed and specified are very, very clear and take into account exactly how we want these assemblies to be built, to make sure that they are built to meet these high-performance targets and the third-party certifications. Because again, don't forget, those third-party certifications are going to have inspections beyond the building code inspections. Someone is going to come out before we install drywall and check all of those things to make sure the installation is installed properly and the air sealing is done and the mechanical systems don't have kinks in the ventilation lines from that exhaust fan and things like that. But also on the tail end, there's going to be final performance commissioning and testing. So we would love for the plans and specifications to be complete and accurate enough for anyone to build off the street. But it is a lot easier if you can develop a relationship with a trade partner who is at least familiar with building some level of high performance or some level of integrated design and better building practices. So that being said, there are some trades in a high performance home that might not make much of a difference when it comes to high performance, like the foundation or the excavation contractor, maybe. In some ways, they still do play an part, but they're a lot less. So time and effort really should be focused on the other trades that do have much more of an impact, from the installation contractor or trade partner to the drywall contractor to the mechanical system designer and the framer or the carpentry contractor, who are very, very key in meeting high performance home targets for durability, window flashing, obviously wall insulation, and mechanical system installation, those kinds of things. So we do have trade partners that we work with that we continue to train, but we also rely on our trade partners to get their own training and stay ahead of the market where they can. So they are truly a trade partner to us and not a subcontractor.
Right. Okay. All right. I think we have time for one last question from Catherine Schumann. How do you find the best / most efficient / sustainable materials? There are so many certifications and ways to word things that end up meaning next to nothing that you have to read through. I think that's a really great question.
It is, and we rely on our design partners to help put us on the right track to up and coming materials that might be coming to market that we have not used before. And we also stick with a lot of the materials that we have used that have proven to meet third-party certifications in the U.S. like Green Guard or like Indoor Air Plus as a stamp or a green label, that we know the backing of them is valid. There's no doubt that there are a phenomenal amount of things that are calling themselves green, from building materials for one way or another. And I'm not trying to dodge the question, but I would, I guess, answer it in summary by saying it is important to install all of those materials, any material, in the right way, following the right manufacturer's instructions. And what we have seen in the past is we've seen high performance green, super energy efficient, or super low VOC, volatile organic chemical certification materials being installed improperly, and essentially voiding or putting those certifications to shame. High performance subfloor or flooring being installed with extremely high chemical content adhesive, or other flooring or carpet surfaces themselves being installed with a high VOC padding underneath it, because the padding wasn't specified. So we stay on top of those to be installed properly, but we also stay on top of them to be specified and tested and validated by our design partner and by the actual manufacturer themselves. I hope that answered the question, Catherine. It was kind of a big question.
All right. Okay, I think that was all the time that we had for today. Honestly, I wish we had more, because I'm learning so much today, and this has been really awesome. And I do want to thank everyone for coming today, and I'm sorry if we didn't get to your question personally, but I did see a lot of similar questions coming in, so I kind of just grouped them together. And Scott, thank you so much for putting this together. This was a really great presentation. And yeah, again, I learned so much today, and I think everyone else did too. So thank you so much.
Of course, happy Earth Day. Please go out and pass it on.
Happy Earth Day. You have a good day today.